So hey guys, welcome to my channel. I am Santosh and here in my channel I discuss topics from physics and mathematics. As usual, today I am here with one more new video for you guys, and in this video I am going to discuss some more questions related to units and measurements. Guys, before starting the discussion, I request you guys to watch the part 1 of this video series, and the link for that video is given in the description below, or else you can also click on the I button to watch that video. So guys, without wasting much of our time, let's get started. Guys, let us begin our discussion with question number 1. The SI unit of universal gravitational constant G is option number 1 Newton meter kg raised to minus 2, option 2 Newton meter square kg raised to minus 2, option number 3 Newton meter square kg raised to minus 1, and option number 4 Newton meter kg raised to minus 1. Guys, before answering this question, let us first see what is this gravitational constant G and where does this term come from. Guys, this term G comes from the Newton's law of gravitation, which states that every particle in the universe attracts every other particle in the universe by a force whose magnitude is directly proportional to product of their masses and inversely proportional to square of distance between them. And this force always acts along line joining the centers of two particles. What does this mean? Guys, if you have two particles having masses m1 and m2 separated by a distance r, then magnitude of force F between these two particles will be directly proportional to product of m1 and m2. So F is proportional to m1 into m2, which means larger the masses of the bodies, then higher will be the magnitude of the force between them. Then we also have another relation, that is force is inversely proportional to square of distance between these two particles, which means F is proportional to 1 by r square. Here r is the distance between two particles. Now, combining these two relations, we can write F is proportional to m1 into m2 divided by r square. So, F is proportional to this ratio. Now, to turn this relation into an equation, we need to introduce the constant of proportionality or proportionality constant. So, finally, we have F is equal to G m1 m2 divided by r square. Here, G is the universal gravitational constant. Now, in the question, they have asked us to find the SI unit of this gravitational constant. For that, what I will do, I will use this relation and keep the term G on one side and bring all other terms on the other side. So, G will be F into r square divided by m1 into m2. Now, from this relation, the unit of G is equal to unit of F into unit of r square divided by unit of m1 into unit of m2. Here, the brackets indicate that we are referring to the units of these quantities. So, unit of G is equal to unit of F into unit of r square divided by unit of m1 into unit of m2. So, unit of F, SI unit of F is newtons, and unit of r, that is distance, is meters. Unit of m1 and m2 are kgs, right? SI unit of mass is kilogram. So, finally, unit of G is equal to Newton meter square per kg square, or Newton meter square kg raised to minus 2. So, answer to this question is option number 2, that is Newton meter square kg raised to minus 2. Guys, next let us move to question number 2. Kilowatt hour is the unit of option number 1 power, option number 2 energy, option number 3 time, and option number 4 pressure. Guys, in this term kilowatt hour, kilo here is the prefix given by SI system of units, which simply means 1000. So, kilowatt hour means 1000 watt hour, and it just makes the unit bigger. Just like if you add kilo in front of meter, you will get bigger unit known as kilometer. And then watt here is the unit of power, named in the honor of Scottish physicist James Watt. And then hour is the unit of time. So, this unit watt hour is the unit of a physical quantity which is combination of power and time. So, this is the unit of a physical quantity which is the combination of power and time. This also implies that watt hour cannot be the unit of power or time alone. So, watt hour cannot be the unit of power or time alone. So, option number 1 and option number 3 are ruled out, because option number 1 is power and option number 3 is time. Then coming to option number 2, we have energy. Energy and power are interrelated. Guys, power in physics is defined as energy transferred per unit time. So, power P is equal to energy E divided by time T. And from this relation I can write energy E is equal to P into T, that is energy transferred is equal to power into time. Guys, from this definition of energy you can get a new unit for energy, that is unit of energy is equal to unit of power into unit of time. Unit of power is watt and unit of time is hour. So unit of energy will be watt hour. Now if we add kilo to this unit, you will get a bigger unit known as kilowatt hour. Then what about option number 4, that is pressure. Guys, pressure on any object is defined as force applied on that object per unit area, that is force divided by area, and the unit of pressure is Newton per meter square, and we also have name for that, that is Pascal. So answer to this question is option number 2, that is energy. Guys, next let us move to question number 3. 1 Fermi is equal to option number 1 10 raised to minus 7 micron, option number 2 10 raised to minus 5 angstrom, number 3 10 raised to minus 3 nanometer, and option number 4 none of the above. Guys, Fermi is the unit of length which is used when we deal with atomic and nuclear phenomena, such a small unit of length. Guys, this unit Fermi is named in the honor of Italian physicist Enrico Fermi for his work in the field of atomic and nuclear physics. And he was the one who started the world's first nuclear reactor. Guys, 1 Fermi is equal to 10 raised to minus 15 meters. 1 Fermi is equal to 10 raised to minus 15 meters. And in SI unit, we also have one unit which is exactly equal to 10 raised to minus 15 meters, and that is femtometer. So 1 Fermi is equal to 10 raised to minus 15 meters or 1 femtometer. Here femto is the SI prefix for the value 10 raised to minus 15. Now what we need to do is, we need to check which out of these 4 options, rather 3 options, is equal to 1 Fermi. Let us see first option, that is 10 raised to minus 7 micron. Guys, 1 micron is equal to 10 raised to minus 6 meters. So 10 raised to minus 7 micron is equal to 10 raised to minus 7 into 10 raised to minus 6 meters, which is equal to 10 raised to minus 13 meters. So this is not the correct answer. Next we have 10 raised to minus 5 angstrom. Guys, 1 angstrom is equal to 10 raised to minus 10 meters. So 10 raised to minus 5 angstrom is equal to 10 raised to minus 5 into 10 raised to minus 10 meters, which is equal to 10 raised to minus 15 meters. So this is the correct answer. Now let us check the third option as well, 10 raised to minus 3 nanometers. Guys, 1 nanometer is equal to 10 raised to minus 9 meters. So 10 raised to minus 3 nanometer is equal to 10 raised to minus 3 into 10 raised to minus 9 meters, which is equal to 10 raised to minus 12 meters. This is wrong, guys. So answer to this question is option number 2, that is 10 raised to minus 5 angstrom. Guys, next let us move to question number 4. Which of the following sets cannot enter into the list of fundamental quantities in any system of units? Option number 1, length, mass and velocity. Option number 2, length, time and velocity. Option number 3, mass, time and velocity. And option number 4, length, time and mass. Guys, for this question I will first tell you which is the right answer, then let us discuss why. Answer to this question is option number 2, that is length, time and velocity are the quantities which cannot enter the list of fundamental quantities in any system of units. Now let us see why. Guys, these 3 quantities, length, time and velocity, are interrelated. That is, each quantity can be defined using the other 2 quantities. For example, velocity can be defined as length upon time, that is basically distance upon time. So velocity can be defined as length upon time. Similarly, the length can be defined as velocity into time. And finally, time can be defined as length divided by velocity. Now come back to the first case, that is velocity is equal to length by time. If you define units for length and time in this case, you will automatically get unit for velocity. How? If you take particular length as 1 unit of length, and if you take particular duration of time as 1 unit of time, then you will automatically get unit for velocity, that is 1 unit of velocity. How? If an object covers 1 unit of length in 1 unit of time, then we say that it has a velocity of 1 unit. Similarly, in the second case, if you define units for velocity and time, you will automatically get unit of length. How? If object of velocity 1 unit moves for a time of 1 unit, then the length that it covers is 1 unit of length. And finally, for unit of time, you only need to define unit of length and velocity. Automatically you will get the unit of time. Now what I'm trying to say here is, if you take any two quantities as fundamental quantities, automatically third quantity will become derived quantity. You cannot define the unit for that third quantity independently. So these three quantities cannot be taken together as fundamental quantities. That is why answer option number 2 is the right answer for this question. Now if you look at other three options, in those options you only have two out of these three quantities, and the other quantity is mass, which can be independently defined, and unit for that also independently defined. Guys, now let us move to final question, that is question number 5. A physical quantity is measured and result is expressed as Nu, where U is the unit used and N is the numerical value. If the result is expressed in various units, then option number 1, N is proportional to U. Option number 2, N is proportional to U square. Option number 3, N is proportional to under root U. And option number 4, N is proportional to 1 by U. Guys, the result of measurement of any physical quantity is always expressed as numerical value followed by a unit. A numerical value followed by a unit. For example, my height is a physical quantity. When I say my height is 165 centimeters, here 165 is the numerical value and centimeter is the unit that is used for measurement. Now in the question what they are asking is, what is the relation between the numerical value and the unit that is used for measurement? Or in other words, what will happen to the numerical value if I choose different units for measurement? Let us find answer to this question using the same example. Here I have expressed my height in centimeters. My height is 165 centimeters. Now what will happen to the numerical value if I choose bigger unit than centimeter? Let's say I choose to express my height in meters. Then my height will be equal to 1.65 meters. Here the numerical value got reduced when I used the bigger unit than centimeter. Now similarly, if I choose to express my height in kilometers, then my height will be equal to 0.00165 kilometers. Again, the numerical value got reduced when I chose bigger unit. Now what is the relation that you can derive from this example? Bigger the unit, the lower will be the numerical value of the measurement, right? Now if you look at the four options that are given, in the first option we have numerical value is directly proportional to unit, which means bigger the unit, higher will be the value. That is wrong, right? So option 1 is not the correct answer. Again, in the second option also they are saying the same thing, that is bigger the unit, higher will be the numerical value. This is also wrong option. In third option also they are saying the same thing, bigger the unit, higher will be the numerical value. Again, this is also wrong option. So if you go to final option, that is N is directly proportional to 1 by U. Here they are saying that lower the or smaller the unit that is used, higher will be the value of numerical value. So this is the right answer. So answer to this question is option number 4, that is N is directly proportional to 1 by U. Guys, with this we come to the end of this video. If you like the video, please hit the like button and also share this video with your friends. And finally, don't forget to subscribe to my channel and click on the bell icon so that you will always be notified whenever I drop a new video. So guys, thanks for watching and stay tuned for the next video.